Hello geometry students, here's your lesson for section 2.5, Algebraic Proof with Missy McCarthy, a math instructor at Oak Miss High School. In this lesson you'll be able to say, I can solve an algebraic equation and provide a justification for each step, and I can identify which property of equality or congruence is being used. So we're going to start talking a little bit more about inductive reasoning, this idea of proof. So what is a proof? It's just an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. If you've ever simplified an expression or solved an equation in algebra, then you've actually really just done a proof. Some of you may remember from your algebra book last year, in section 2.5, you were using deductive reasoning in order to justify your steps for simplifying an expression or solving an equation. So we're going to do more with that this year. In order to do that, you're going to need some justification, some properties. And we're reviewing all of the properties that you guys have studied in the past, but we may add a couple of different ones to it. So the addition property of equality just says that you can add the same thing to both sides of an equation and not change its value. The subtraction property of equality says the same thing. You can subtract the same thing from both sides and not change the balance of the equation. Multiplication property, you can multiply both things, and the division property, you can divide both sides by the same number as long as that number isn't 0 and not change the equation. The reflexive property just says that something is equal to itself. So in this case, they've given us the example A is equal to A. That's what we call the reflexive property. The symmetric property says if A is equal to B, then B is equal to A. That's what allows you to move things back and forth. For example, if we had 7 equals X and we wrote X is equal to 7, we were actually just using the symmetric property of equality. The transitive property is if A equals B and B equals C, then A equals C. That's very similar to the law of syllogism. And lastly, the substitution property, which says if A is equal to B, then B can be substituted in for A in any expression. So let's see how this will come into play in our algebraic proofs. So you'll be given an equation. In this example, the equation is 4m minus 8 equals negative 12. And we're going to solve this equation and justify each step with one of those properties from the previous page. So we're going to start off with our equation, 4m minus 8 equals negative 12. And our justification for that is just going to be that this was the equation that was given to us. That is an acceptable justification. The first thing that I would do to this equation is add 8 to both sides. And I'm going to do it beside it instead of beneath it, just to keep everything in line. So what property allows us to add 8 to both sides? That would be the addition property of equality. You can write it in shorthand like that if you need to. And then for my next step, I'm just going to combine these like terms, so I'm left with 4m equals, and I'm going to combine these like terms over here, so I'm left with negative 4. Whenever you're just doing the arithmetic, negative 8 plus 8 or negative 12 plus 8 on either side, and you're not changing each side, you are allowed to just say, I'm just simplifying here. That's your justification. You're just adding the numbers together. You're simplifying. The next step is going to be to divide both sides by 4. So I'm going to write 4m divided by 4 and negative 4 divided by 4. And all I used there was the division property of equality. And then I'm going to simplify again to get m is equal to negative 1. And what was I doing there? I simply just divided on both sides. So I can say my justification for that was simplifying. And we've just done our first algebraic proof. With each step, we've gone down and justified everything with a property. Okay, like in algebra, geometry also uses numbers and variables in operations. So here's an example that uses the segment addition postulate. And we can justify each step of this proof that involves some geometry concepts just exactly the same way that we did when we were doing with algebra. So you're given this diagram, And the first thing that you write is that NO is equal to NM plus MO. What allows us to say that? Well, we are allowed to say that by the segment addition postulate. The segment addition postulate. And then if we take NO and we replace it with 4x minus 4, we take NM and we replace it with 2x, and we take MO and we replace it with 3x minus 9. What allowed us to do that? Well, the property that said that we're allowed to substitute. So that would be the substitution property of equality. All right, so then we left this side the same. The 4x minus 4 stayed the same. On this side, we combined the like terms. So we didn't add anything to both sides or divide or anything like that. We just simply combined our like terms. So again, if we're just working on one side of our equation, we can say all we were doing there is simplifying. Okay? Then from this step to this step, let's see, for that negative 4, it looks like we decided to subtract 4x from both sides. Now that's not shown, but that's the only way we can get negative 4 equals x minus 9. So because we subtracted 4x from both sides, that would be the subtraction property of equality. Okay, and lastly, it looks like we added 9 to both sides to get x, or 5 equals x. So in order to get there, we use the addition property of equality. And we've just justified each step. Now lastly, I would probably say, instead of leaving it as 5 equals x, I would probably say for my next step, that means x equals 5, and I am using what we call the symmetric property of equality. And we've just done a combination of geometry and an algebraic proof. Not only do we have properties of equality, but we also have properties of congruence. And the properties of congruence that we're going to use are the reflexive, the symmetric, and the transitive property. If we're saying that figure A is congruent to figure A, a figure is congruent to itself, that's what we call the reflexive property of congruence. An example of that would be that segment EF is congruent to segment EF. The symmetric property of congruence is very similar to the symmetric property of equality. If figure A is congruent to figure B, then figure B is congruent to figure A. Or if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. That is an example of the symmetric property of equality. And lastly, just as we of congruence. And lastly, just like we had the transitive property of congruence of equality, we have the transitive property of congruence. If figure A is congruent to figure B and figure B is congruent to figure C, then figure A is congruent to figure C. That's a lot like our law of syllogism. So here's an example here. If segment PR is congruent to segment RS, and segment RS is congruent to segment TU, then segment PQ, and I read that wrong. If segment PQ is congruent to segment RS, and segment RS is congruent to segment TU, then that means that segment PQ is congruent to segment TU. Again, very similar to the law of syllogism. So let's just see if we can identify what we're using here for each of these. Angle QRS is congruent to angle QRS. That is what we call the reflexive property. Reflexive property, and this is a property of congruence. It is not a property of equality. If the measure of angle 1 equals the measure of angle 2, so the measure of angle 2 equals the measure of angle 1. Because it's equals, we know it's the symmetric property, but it's the symmetric property of equality. Segment AB is congruent to segment CD, and segment CD is congruent to segment EF, so segment AB is congruent to segment EF. That's similar to our law of syllogism, and it is what we call the transitive property, and this is the property of congruence. And then 32 degrees is equal to 32 degrees. That's a property of equality. And when we say something is equal to itself, that is what we call the reflexive property of equality. So that goes with your second I can statement. I can identify which property of equality or congruence is being used. And that wraps things up for us. So in class, we're going to practice solving some algebraic equations and providing a justification for each step and identifying which property of equality or congruence is being used. That's it. See you in class.